Right, so as a quick review as to what is power factor correction. So if you remember from last week when we were talking about power factor correction, we were talking about if you had a circuit that was an RL circuit, so some kind of RL load, like a motor load, something like that. And it would have its phasor diagram. Taking the voltages being the reference. Your IRL would be somewhere like that. And then you'd have your phase angle for your circuit in there as well. So that would be the kind of circuit you would use for power factor correction. And to power factor correct, or what you do when you power factor correct, is you add in a parallel capacitor. So that's your power factor correction capacitor there. So when you add in your power factor correction capacitor, the value of the capacitor you choose will give you a value on this axis here. Say that was it. And then when you add them together as phasors, IRL plus IC, you would get a value of IS, which is smaller than your original IRL, so you've reduced the supply current, and your phase angle for the circuit would be smaller than your theta IL, so your power factor would be closer to 1. That's what you do when you power factor correct, and that's your power factor correction capacitor. So you pick an appropriate value of capacitor to give you a value of capacitor current that when you add on to the end of IRL, will significantly reduce your IS, which was originally your IRL, moving up that axis. It will reduce that angle, and if you can get that angle close to 0, your power factor will become close to 1. That's what power factor correction was. Okay.